Miss Frizzle, what is this?
Oh, class, this is a picture of a bacteriophage.
What is a bacteriophage, Miss Frizzle?
Well, a bacteriophage is a virus that affects bacterial cells.
How does a bacteriophage infect a bacterial cell?
Great question, Andy. Well, the lactic cycle begins with a step called attachment. And in the attachment phase, a bacteriophage uses its complex tail fiber structure to aid the attachment to the cell wall of the bacterial cell. Once attached, weak chemical bonds are formed. This helps hold the bacteriophage and the host cell together.
Wow, what happens next?
The next step in the lactic cycle is called the penetration stage. In this stage, the attachment bacteriophage injects its DNA or RNA, depending on the specific phage, into the host cell. This is accomplished by releasing enzymes that weaken the cell's wall of the bacterial host cell. The genetic material is injected by pressing its sheath against the cell. The empty capsid or virus body then remains in the bacterial cell. Some phages even enter the cell intact and dissolve their capsid inside the host in a process called encoding.
Ow! Something bit me!
What happened, Jordan?
I don't know, but I felt a little ticklish.
Well, class, we're gonna go on a field trip to see Jordan's arm.
Yes! Are you sure about this?
Alright, class, all aboard.
Seatbelts, everyone! Please let this be a normal field trip. With a friend? No way!
Cruising on down Main Street, you're relaxed and feeling good. Next thing that you know, you're seeing octopus in the neighborhood, surfing on a sound wave, swinging through the stars. Take a left at human testing, take your second right past Mars on the magic scuba, alligator nostril, climb on the magic scuba, spank a plankton too.
Take that!
On our magic scuba, drop the river of lava. On magic scuba, such a fine thing to do. So strap your bones right to the seat. Come on in and don't be shy. Just to make your day complete, you might get baked into a pie on the magic scuba. Step inside, it's a wild ride. Come on, right on the magic scuba.
Well, here we are, class.
Whoa, jeepers.
Dang, there's a lot of blood around here.
Oh snap, what was that? Those are red blood cells, doofus.
Hey, don't come to. Alright, class, if you look over to your left, there is a bacterial cell. And here is a bacteriophage that is coming to infect this bacterial cell. Can anyone explain what is happening?
Well, the first step in the lytic cycle is attachment. Phages don't seek out host cells, they collide by chance and attachment occurs. There is an attachment site on the phage that attaches to a complementary attachment site on the bacterial cell, through which weak chemical bonds. The cool tail fibers are what help the phage attach.
Ooh, I know this one. The next step is the penetration stage. The phage has to secrete an enzyme called phage lysozyme through its tail, which helps break down a portion of the bacterial cell wall. When the tail sheath of the phage contracts, the tail goes completely through the cell wall, all the way to the membrane. Once it gets in there, the DNA from the head goes through the tail core and gets into the host cell. The phage kind of reminds me of a syringe like those mad scientists used to inject people with.
Ha, you forgot another important part. Following the penetration stage comes the biosynthesis stage. After the phage transfers all of its DNA into the host, the phage DNA replicates and phage proteins are made. The phage uses the host cell's enzymes and nucleosides to build many copies of phage DNA, and then the biosynthesis of viral proteins begins. After several minutes following infection, no complete phages will be found in the host cell.
Man, I love students that do their homework.
Then comes maturation, where bacteriophage DNA and capsids are assembled around the core of viral DNA. The head and tails of the phage are assembled separately from protein subunits and then the head is filled with phage DNA and attached to the tail.
Finally, the last stage of the lytic cycle is release, where the plasma membrane of the cell breaks open or lyses, causing newly made phages to get released from the host cell. Lysozyme is synthesized within the cell, which causes the bacterial cell wall to break down. This causes the newly made phages to be released from the host cell. These phages can then infect other susceptible cells, and the lytic cycle can then be repeated within those cells. The lytic cycle ends with the death of the host cell.
Excellent, class. You see, Jordan, there's nothing to be afraid of.
Did you bring a marker in Jordan's body?
Maybe.
Can you guys get out of me now?
Ow! Wow, I learned so much today.
You ain't the only one.
That was crazy.
Well, class, I hope you guys learned about the lytic cycle.
Is this the magic school bus? Is this the magic school bus? Magic school bus? Magic the magic school bus? You mean magic school bus? Magic school bus? Magic school bus? Magic school bus? I wonder what a magic school bus. Oh, the magic school bus.
Hello, is this the magic school bus?
Well, yes, hello. How may I take your call?
I have a question about bacteriophages. Do they always behave the same way throughout the lytic cycle?
Alterations in the environmental conditions that a lytic cycle is performing and can help or hinder the success of the lytic cycle. For example, if an organism does not have a significant number of respiring cells or organic carbon, then the lytic cycle will not be successful and the bacteriophage will fail to interact with the host.
Oh, I see. Thank you for your help.
Hey, is this the magic school bus?
Why, yes it is. How may I help you?
Bacteria have been growing resistance to antibiotics for years. Is there something else we can do to stop them?
As a matter of fact, there might be. Bacteriophages are some of the most ubiquitous organisms on Earth and can prove to be fruitful in the fight against bacteria. Bacteriophage therapy is becoming increasingly popular since antibiotics are not working as strongly as before. Phage therapy has a high therapeutic index, allowing few side effects during treatment, and is normally harmless to the host organism. Phages are extremely specific, much more so than the typical antibiotic, and would be able to solely target the bacteria that is causing harm.
Phew. Well, hopefully phage therapy will prove beneficial. Thanks for your help.
Well, hopefully that's all the calls for today.